What's up? Welcome back to my tutorial channel. Daniel's here, and today I'm gonna continue on topic 3, numerical summaries or descriptive statistics. So remember last video I only introduced you the measures of center. Today we're going to talk about measure of spread. So to measure how the data set spread around the center, we either can use the range or variance or standard deviation. We also can apply empirical rule in some cases or Chebyshev rule, and we also can use coefficient of variation in some case. So first, let's start off with the range. The definition of the range is very simple. The range of a dataset is the difference between the largest value and the smallest value. The range is computed as largest value subtract smallest value. For example, compute the range of the temperature data for San Francisco and St. Louis. So here's the data sets of 12-month temperature in San Francisco and St. Louis, and we are going to compare the ranks of these two cities. So for the first city, San Francisco, the largest value of temperature is 63 and the smallest temperature is 51. So the range for temperature for San Francisco is 63 subtract 51, which is 12. Similar for St. Louis, the largest value of St. Louis temperature is 79 and the smallest is 30 Fahrenheit. So the range for St. Louis temperature is 79 subtract 30, which is 49. So here we see that St. Louis temperature varies more widely compared to that of San Francisco. So here the good thing of range, the advantage of using the range to measure how the data set spread around the center is the range is very easy to be computed, which is basically take the largest value, subtract the smallest value. However, there is a disadvantage about the range. That is, the range takes into account only two values, the smallest and the largest. So any number between them does not contribute to the range. So in some case, the range is not the good way to measure the spread, and we prefer using the variance. So second, the variance. And remember when we learn about the mean, we have the population mean and the sample mean. So for variance, we also have population variance and sample variance. So first with population, let x1, x2 to x capital N denote the values in the population of size capital N, and let mu denote the population mean. The population variance denoted by sigma square is computed as sigma square is sum of square of difference between its value and the population mean, and then divide the whole thing by the number of observation. So sigma square is summation of x minus mu whole square over n. And for sample, let x1 to x little n denote the values in the sample of size little n. The sample variance denoted by s square is s square equal to summation of x minus x bar whole square divided by n minus 1. The formula is the same as the population variance, except that we replace the population mean mu with the sample mean x bar, and we divide by n minus 1 rather than capital N. So when you read a question asking you about computing the variance, make sure you know if you are asked about population variance or sample variance. For example, a company that manufactures batteries is testing a new type of battery designed for laptop computers. They measure the lifetimes in hours of 6 batteries, and the results are 3, 4, 6, 5, 4, and 2. Find the sample variance of lifetimes. So here, the question doesn't mention if this is a population or a symbol. However, you need to use common sense in this situation. Here they measure the lifetimes in hours of sick batteries. So sick batteries cannot be a population because it doesn't represent for all batteries. So the sick batteries here is basically just a symbol. That means this question is asking for symbol variance. So to find the symbol variance, we first find the symbol mean because symbol mean is one of the factors that is used to find the variance. So first we have to find symbol mean. Symbol mean, remember the last lesson, I show you how to find the symbol mean. We basically add all number together and divide by the number of observation. So 3 plus 4 plus 6 plus 5 plus 4 plus 2, divide them by 6, and we got x bar is 4. The symbol mean is 4. Now we use this symbol mean to find the symbol variance. So s squared is number we are going to subtract the symbol mean 4 and then square and continue to finish the other number. Do the same thing to repeat it. And after that, add all of these squared together and divide it by n minus 1. Remember, for symbol variance, we divide it by n minus 1, not capital N. So it's 6 minus 1 at the denominator. And the answer for symbol variance is 2, because 10 over 6 minus 1, so it's 2 for the symbol variance. So that's how we compute a symbol variance. So the variance is more complicated to be computed than the mean, than the range. However, the variance takes all of the values into account. Next, standard deviation. The standard deviation is basically just the square root of variance. So first symbol standard deviation, s is the square root of the symbol variance, s squared. So s is square root of s squared. And the population standard deviation, sigma, is the square root of the population variance, sigma squared. So to find standard deviation, first thing first, we have to find the variance and to basically take the square root. No matter is population or symbol, we basically just take the square root of the variance. Example, find the symbol variance and the standard deviation for the following symbols. Here, the question gives you a set of 8 numbers. So to find the standard deviation, we have to find symbol variance. But to find symbol variance, we need to find symbol mean first. So the first step is find the symbol mean. So we add all these numbers together, divided by 8. And we got 2.5 for the mean. Now we use the symbol mean to calculate the variance. So symbol variance is using the formulas. We got 3.7143. And then for the standard deviation, we basically take the square root. So standard deviation s is square root of s squared. And we got square root of 3.7143. Again, all of these numbers we work under a symbol because they give you a symbol. If the question gives you a population, this should be mu, this should be sigma squared, here should be 8, not 7. And standard deviation, it should be sigma equal to square of sigma squared. So keep that in mind. So now we are going to approximate the standard deviation with group data because sometimes we do not have access to the raw data. And sometimes it's more convenient to collect dataset using group data. So here's an example. Calculate the variance and the standard deviation for number of text messages. Here the dataset is collected under group data. So the number of text messages is classified into 6 classes. The first class from 0 to 49 text messages a day. The second class is 50 to 99 text messages a day. The third class is 100 to 149 text messages a day. 150 to 199 text messages a day. 200 to 249 text messages a day. 250 to 299 text messages a day. So to find the variance or standard deviation, we need to find the mean. Remember in the last video I showed you how to approximate the mean for group data. We need to find midpoint, then use the midpoint as a representative for each class. So for the first class, to find the midpoint, we use the lower class limit at the lower class limit of the next upper class and divide by 2. So 0 plus 50 divided by 2 is 25. Then continue 50 plus 100 divided by 2 is 75. 100 plus 150 divided by 2 is 125, and so on. So we collect the midpoint, which is the second column. And to approximate the mean, we take its midpoint, multiply its frequency, then add all them together and divide by the total of frequency, which is 50. So we got the mean for this group dataset is 137 text messages a day. Then now to find the variance, we need to find the deviation between the mean and the midpoint. So we take its midpoint minus, subtract the mean. So we have 25 subtract 137 is 112, and repeat for the other classes. Next, we square this deviation, because if we don't square and just add up without squaring this deviation, they're gonna add up to be 0. But that's not what we expect to have in the dataset. So we need to square this column, its number in this column, then time with its frequency. So negative 112 square is 12,544 times its frequency is 10. So for the first class, we got 125,440. Then do the same thing for the other classes. We collect 6 numbers represent for 6 classes. Then add all these together. We got the total is 222,800. Now to find the variance, remember this is symbol variance, so we have to divide by number of classes minus 1. So number of frequency minus 1. So we have 50 minus 1, because here we collect the data set of 50 people. So the degrees of freedom is 49, n minus 1. So the symbol variance here is approximated as 292,800 divided by 49. We got 5,975.51020. Then for the standard deviation is symbol, which is basically take the square root of the variance, and we got the symbol standard deviation is 77.3014. So that's how we calculate the standard deviation and how we approximate standard deviation. Now sometimes we also can use empirical rule to tell us how the data set spread around the center. The empirical rule, there is a limit for this rule, is it should apply for symmetric data set. So sometimes when you make the histogram of the data set and you realize it's symmetric or roughly symmetric or approximately symmetric, we are able to use empirical rule to approximate the percentage of data sets and see how the data set spread around the center. So here's a rule. When a population has a histogram that is approximately symmetric bell-shaped, approximately 68% of the data will be within one standard deviation of the mean. So here this is mean. Mean subtract sigma and mean plus sigma, we got a range. And this range is called one standard deviation. So 68% of the dataset will fall within this range. So that means 68% of the dataset is between mu minus sigma and mu plus sigma. 95% of data will be between mu minus 2 sigma and mu plus 2 sigma approximately. And all or almost all of the data will be within 3 standard deviation. Actually, it should be 99.7, but here it's approximately almost. And this empirical rule I'm gonna explain more in detail when we work with normal distribution. So here I just want to let you know we also can use empirical rule to to illustrate how the data sets spread around the center. So empirical rule, there is a disadvantage. That is, empirical rule is just applied for symmetric data sets. So when the data set is not symmetric, we can use different rule. It's called Chebyshev inequalities. So the Chebyshev inequalities is as in any data set, the proportion of data that will be within k standard deviation of the mean is at least 1 minus 1 over k squared. Specifically, by setting k equal to 2, k equals to 3, we obtain the following result. So at least 34, which is 75% of data, will be within 2 standard deviation of the mean. That means between mu minus 2 sigma and mu plus 2 sigma. At least 8, 9, which is 88.9% of the data, will be within 3 standard deviation of the mean. That means between mu minus 3 sigma and mu plus 3 sigma. For example, as part of a public health study, systolic blood pressure was measured for a large group of people. The means were 120 and the standard deviation was 10. What percentage of people has had systolic pressure, blood pressures between 100 and 140? So here we notice 120 is the mean, and we consider an interval from 100 to 140. So 100, the difference between 100 and 120 is 20, which is 2 times standard deviation. And the difference between 140 and the mean is 20, which is 2 times standard deviation. That means this rank is basically 2 standard deviation. So using Chebyshev inequality, we have at least 1 minus 1 over 2 squared, which is 75% of people had systolic blood pressures between 100 and 140. Remember, k here is 2 because we consider 2 standard deviation. And the good thing of Chebyshev inequality is it's applied for any data sets, not necessarily symmetric. Even skew or not skew doesn't matter. And however, for Chebyshev inequality, they just tell you at least what is the at least percentage, but they cannot tell you the exact value. Coefficient of variation. Sometimes when you compare two variables but using different units of measurement, and we want to see which variable have a wider spread, so we need to use coefficient of variation. The coefficient of variation is found by dividing the standard deviation by the mean. So CV is sigma over mu. The coefficient of variation, CV for short, tells how large the standard deviation is relative to the mean. It can be used to compare the spreads of data sets whose values have different units. For example, National Weather Service records show that over a 30-year period, the annual precipitation in Atlanta, Georgia, had a mean of 49.8 inches with a standard deviation of 7.6 inches, and the annual temperature had a mean of 62.2 degrees Fahrenheit with a standard deviation of 1.3 degrees. Compute a coefficient of variation for precipitation and for temperature, which had a greater spread relative to its mean. Here you see like the precipitation and temperature have different units of measurement. So if we use standard deviation or variance to compare them, it's become nonsense. Like it's meaningless. So variance and standard deviation, even range, fail in this situation. So we need to use a coefficient of variation. So we find a CV for precipitation. We got CV is sigma over mu, so it's 7.6 over 49.8, and we got 0.153. Same for temperature, we have CV is 1.3 over 62.2, we got 0.021. And here we see that the precipitation has a greater spread relative to its mean. So that is everything for today. Thank you so much for watching my video. Next video, I'm going to talk about a measure of position. So see you next time.